Hello, today we are going to talk about graphing quadratics in Vertex form. So we are going to look at the equation y equals a parentheses x minus h squared plus k. That is going to be in Vertex form. And we want to pay close attention to our vertex, which is hk. So looking at the h value, if you look inside our parentheses, we have x minus h. And then we have this h here. So if we notice that there's a minus in front of h, that means that when we find our vertex, we need to flip the sign and take the opposite. So if it was x minus 2 squared, we would use 2 as our x value for our vertex. The k value is exactly the same as what it is out there. So if you have that x minus 2 squared plus 3, then our k value would just be 3. We don't change anything with that. If it was minus 5, then we would use minus 5. Same thing with standard form and vertex form is that if a quadratic opens up if a is greater than 0, opens down if it is less than 0. And then we talked about in the previous video, y equals x squared is our parent graph, so it's this red function over here. And we graph these 5 points on the left side, negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4. And more specifically, we only graphed these 3 points moving forward from the vertex, and then we reflect it across our axis of symmetry. So if you have questions on how to graph those specifically, then please refer back to the video on graphing standard form. So we're going to look at this first equation. So we're going to look at x minus 3 squared plus 2. We are in vertex form because we have parentheses quantity squared, however you want to word it. And we want to look first at our a value. So the a value is the only thing that transfers over from standard form. And if there's nothing there, we're going to say there's an understood 1. So 1 is positive, meaning it's greater than 0. So this is going to open up. It also means that once we graph our vertex, we're going to graph our parent graph the same way that we did on the previous slide. Our vertex, we're going to look at this x minus 3. And like I said in the previous slide, we're going to always take the opposite of that. So that's going to become positive 3. And then your k value, we take the same sign as it is there. And then our axis of symmetry is going to be x equals 3. That is the same as your x value of your vertex. So we're going to graph I'm going to graph the axis of symmetry first. Remember, that is just your vertical line that passes through the vertex. And then when we go to 3, 2, and we plot our point there, now we graph our 3 points, so our vertex, and we are not doing any stretching or shrinking, so we can go right 1, up 1, just like the parent graph, and then go back to your vertex, go right 2, up 1, 2, 3, 4. And then we want to reflect that across the axis of symmetry, and you have a quadratic that looks like that. Looking at the second example, so we have f of x equals 2 times the quantity x plus 1 squared. We want to look at our a value of 2. So that's going to tell us that we are going to open up because 2 is greater than 0. And then we're going to look at our h value, which is this plus 1 right here, but we're going to take the opposite of that and we're going to say that that's negative 1. Again, that means our axis of symmetry is x equals negative 1. From there, we want to look at something that says, what is out here? What are we adding for our k value? And if there's nothing out there, we are adding 0. So we should have negative 1, 0. So don't add anything in. Don't use 2. If there's nothing out there, then we don't want to worry about that. The other thing, too, we need to make sure of is that we said that a is equal to 2. And that's going to affect our graphing. It affects whether we open it up or down, but it also affects our graphing of our parent graph because we are no longer graphing our parent graph. So what that means is we're going to graph our axis of symmetry first. So we're at negative 1. We have negative 1, 0. And our parent graph says from there we can go right 1, up 1. But we need to take into account this 2 that affects the up values. So we're still going to go right 1, but we're going to go right 1, up 1, 2. And then we go back to our vertex, and we normally go right 2, up 4, but we're going to go 4 times 2, which is 8. Same thing going, we can use the axis of symmetry for the left side to get those 2 points, and those give us our 5 points that we want to graph. And so you have a quadratic now that has been moved off the origin but also stretched vertically. So the a value only affects the up and down portion, not the left or right portion. All right, looking at one that is a little bit more complex. It looks more complex, but it's really not that bad if you take it piece by piece. So we have 1/2 out in front. That is a. That is greater than 0. So that is going to open up. Just because it is a fraction, that means that if we were talking transformation-wise, that would be a shrink. It's still going to open up. But I am going to make a note that our a value is 1/2. So when I graph that, I can remember to take that into consideration. Opposite with x, so that's going to be -4 for our h value. And our axis symmetry is going to be x equals -4. And then our k value is -2. We use the same exact sign there. So once you have those characteristics, we can go ahead and graph, but we need to remember about this 1/2 when we graph. So graphing our axis of symmetry, we're at x equals -4. And we can go to -4, -2. And from there now we're going to say our parent graph normally goes right one, up one, but we're going to go right one, up 1 times 1/2, which is kind of tough to graph, but it just needs to be somewhere in between those two. It doesn't have to be perfect. But you're at the y value of -1.5. Then we go back to our vertex, and we're going to go right 2. Parent graph goes up 4, but 4 times 1/2 is 2. So we're going to be at this point when y is 0. Again, we reflect across. It doesn't have to be perfect. It just has to be close. And then we reflect across there. And what I mean by it doesn't have to be perfect is as long as you're between -1 and -2 in your y value, I will count that correct. So you don't have to be exactly in the middle. But if you are way off and if you're in between 0 and -1, that will be marked incorrect. Lastly, we're going to put everything together. So we're going to have all sorts of transformations going on from our parent graph. So we are still looking at our a value first to tell us whether it opens up or down. And -3 is less than 0, so that's going to open down. And I'm going to make a note that our a value is -3 because that's going to affect our when we graph. So your vertex is opposite of what's inside with x, so 1, and k value is 7. Our axis symmetry is just our x value of our vertex, and so that gives us our vertical line. So I'm going to go ahead and graph that. And then we're going to go to 1, 7. Now, we are opening down because of the negative part, and it's going to be stretched by 3. But you can take care of that all in one step. So what that means is we normally, our parent graph goes right 1, up 1, but we are going to say 1 times -3 means -3 or down 3. So we're going to go right 1, down 1, 2, 3. And we have a point there. Same thing, we go back to our vertex. Our parent graph, we go right 1, up 1, 2, 3, 4. But we are going to say 4 times -3 is -12. So you have to go right 1, down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we have a point there. Once you do that, you reflect across the x-axis, across the axis of symmetry. And we have this parabola here. So I hope this has helped. Make sure that you are remembering to graph 5 points whenever possible. All of your graphs should be fitting on a 10 by 10 graph for the most part.